Today we're going to talk about structures of rational expressions. A rational expression is a ratio of two polynomials in which a variable appears in the denominator. So let's explain that a little more. First of all, here's an example of a rational expression. Remember, the term ratio means a fraction. So in other words, I have a fraction where I have a polynomial in the numerator and denominator, and I'm going to have at least one variable in the denominator. Quite often you can simplify a rational expression by factoring and reducing. So that's what we're going to focus on today, is the factoring and reducing part. So let's do a little investigation. First of all, let's do 2x over 8. We're going to do a little bit of factoring here. Now really what we're going to do is reduce a fraction. So remember when we were factoring the other day, we took out what they had in common. When you reduce a fraction, that's kind of what you're doing here. They both have a 2 in common. The numerator and denominator can both be divided by 2. So I'm going to take out a factor of 2. In the numerator, that's going to leave me with just an x. In the denominator, when I take out a 2, it's going to leave me with a 4. We're going to look for something that could be the same in both the numerator and denominator, and that's where our reducing comes in. In other words, if they have something in common that's being multiplied in both numerator and denominator, they can cancel. Now, cancel is technically not the right word for it. That 2 over 2 doesn't really cancel, they just reduce to 1. So when I have 2 over 2 times x over 4, 2 over 2 reduces to 1, and 1 times anything is just itself. So I end up with just x over 4. Let's look at another example. I have 2 over 8x this time. Looks really similar to what we had before. But now this is a rational expression because I have an x or a variable in the denominator. Again, I'm going to take out what they have in common. Both of these numbers can be divided by 2. So when those 2's reduce out of the picture, I'm left with 1 over 4x. We want to be careful now. We're going to talk about domain a little bit. First of all, in any fraction, remember you can't have 0 as a denominator. So 4x cannot be equal to 0, which means that x can't be equal to 0. When we talk about rational expressions, we need to be careful and put a limit on, or a restriction rather, on what our x values can be. In this case, I'm going to put on the condition that x can't be 0. So as part of my answer, I'm actually going to put 1 over 4x when x is not equal to 0. So let's look at another one. Here again, I have a polynomial in numerator and my denominator. In the numerator, there's not a lot that I can do anything with, but look at the denominator. That's a factorable quadratic expression. So I'm going to factor the denominator. Numbers that will multiply to -10 and add to -3 gives me factors of x minus 5 and x plus 2. Then we're going to look for factors that are in the numerator and denominator that they have in common, like before when we had the 2 over 2. Since I have an x minus 5 and an x minus 5, those can reduce right out of my fraction. I'm going to be left with 1 over x plus 2. Remember, nothing actually disappears. It just reduces to 1, so I still have a 1 in my numerator. Now, this isn't my final answer though, right? I have to put a restriction on it. I cannot have a fraction with a denominator of 0. So what you have to ask yourself is, what number can I put in here for x that will make my denominator 0? What plus 2 equals 0? And that would be a -2, right? So a -2 is forbidden down here, but take a look up here as well. Remember when we had our factors and I had an x minus 5? I have to take into consideration both of these factors that ever appeared in my denominator, not just what I end up with in the end, or in my final answer. So x can't equal 5 and x can't equal -2. So I'm going to put both those restrictions in my answer. So for those of you whose heads are spinning, let me remind you why that is. Here in my denominator, I have an x minus 5. Let me rewrite that. I have an x minus 5, and I have an x plus 2. Basically, what I'm doing to find my restrictions is setting those equal to 0. If I add 5 to both sides, I get x equals 5. And over here, if I subtract 2 from both sides, I get x equals -2. These are the numbers that x cannot equal because they make my denominator 0. Be careful with those. I have to look at every denominator in my problem, right? Even as I go through the whole problem, look at every denominator and make sure you've covered all your bases. Let's look at one more. Here I've got a monomial top and bottom, right? Hopefully you've seen this in the past. If not, this is going to be something new for you. But remember, 12x squared y to the 5th means 12xx times y times y times y times y times y. In the denominator, I have a 4, 1x, and 2 y's. So I'm going to look for things that they have in common. So for instance, my numerator has an x and my denominator has an x. And since everything is being multiplied everything is being multiplied here, if there is any addition and subtraction, this could not happen. But an x over an x is going to reduce to 1, and a y over a y would reduce to 1. So there's 1x and 2 y's that I can reduce right out of the picture. In addition to that, 12 over 4 can reduce to 3 over 1. So then I look at what I have left over. In the numerator, I have a 3, an x, and 3 y's. So I get 3x y to the 3rd. In the denominator, basically nothing is left except for that 1. Anything over 1 is just itself. I don't ever want to leave my answer as being over 1. So here I have my final polynomial, kind of, right? I need to look for restrictions. I'm going to go through every denominator and see if there's any values for x or y that would make my denominator 0. Is there anything that I could put in for x that would make this denominator 0 or y? This is the same denominator down here before it was reduced anyway. Well, multiplying by 0 would make anything be 0. So x and y can't be 0. Neither of them can be 0. So I'm going to put a restriction for both. X can't be 0 and y can't be 0, so that all of my fractions don't become undefined. Remember as you go along to look for denominators and find any values for which x or any other variable could be restricted, right, where they would be equal to 0. And if you need extra help on factoring, since factoring is going to be a big part of this section, you can find extra videos on Khan Academy or YouTube or pretty much any Google search, or you can come see me during charger time or after school. Have a great day, and I'll see you later.